Hello and welcome to today's video by my physics teacher all about kinetic energy. We'll start by looking at the equations and units for kinetic energy, then going through how to rearrange the equation, go through some examples, and then you'll have an opportunity to attempt some questions and then I'll go through the answers. As with all the videos, I expect you to make sure that you brought your brain along with you today, make sure that you have a pen and paper and also your trusty calculator. So if you're missing one of those things, go and get it before you carry on with the rest of the video. It's always really important to try and recall what you already know about a topic. So what I'd like you to do, please, is press pause, think about what you can remember, and write down your ideas onto your piece of paper. And then once you've done that and got everything out of your brain that you possibly can, then we'll carry on going through the video. So if we start with the equation for kinetic energy, now it's often written as EK equals a half mv squared, where E stands for energy, K stands for kinetic, so kinetic energy, and then some people write the half as 0.5, or they also write it as mv squared divided by 2. I also recommend, as well as learning about the letters, to use the full words. In the exam, they won't say m equals, they will say mass equals. So if you can remember kinetic energy equals a half times mass times velocity squared, then that will help towards your exam. It's also worth mentioning that it's the velocity that's squared only. You do not square the whole thing, you just square the velocity. And with all equations, it's clearly important to know the units. So kinetic energy, clues in the name, it's a type of energy, so the unit is joules. Do not ever write a little j because you're at risk of losing a mark. Mass is measured in kilograms, so kg, and velocity is meters per second. A reminder, velocity is a posh name for speed, where it's the speed with a direction. It's a vector quantity. When trying to rearrange the equation, a triangle can be a really useful way of helping you do that. So with this, it is possible, even though there are 3 parts to the equation on the right hand side, where normally there might only be 2. So for example, in force equals mass times acceleration. So it is possible, and I'll show you how. Before I do though, try and have a go yourself. And then once you've had a go, watch the rest of the video. The first step is to put the line across to show the divide sign, and then we've got 2 multiplication signs as well. Now, we can start by putting kinetic energy at the top, and then we can write a half times mass times velocity squared. Now, whilst triangles are really useful, it is ideal really if you can rearrange an equation using maths. So let's have a go for doing m, or mass, equals. So first step, if we want mass by itself, is to multiply by 2, because if we multiply both sides by 2, 2 times a half equals 1. So 2 times kinetic energy equals mass times velocity squared. Then we need to move the velocity squared to the other side of the equation. So 2 kinetic energy over v squared equals mass. So we can then write that as 2 ek over v squared. So let's just compare that to our triangle that we wrote on the previous page. So we cover up the term mass. So mass equals ek over a half v squared. Notice, although I've got a 2 on the top of this equation and a half at the bottom of that equation, mathematically they're exactly the same. So we can check our answers and they're both equal. So regardless of the method that you want to use, you've now got 2 options. Let's now look at how to rearrange for v, or velocity equals. So we can start with the same idea, multiply both sides by 2 to remove the half. So we get 2 ek equals m v squared. So now let's move the m to the other side by dividing. So 2 ek over m equals v squared. Now what we're looking for is v by itself, and we've currently got a v squared term, so we've got one final step to do, and that's what makes this equation a little bit trickier than others. So you have to square root the equation on both sides, the square root of 2ek over m, and that's then equal to the square root of v squared, which gives you v. So v equals 2ek over m. This is why rearranging it mathematically is far superior than just relying on our triangle, because it wouldn't necessarily do the final step. However, it can still be used. So just like normal, you would cover up the term that you want to find. So v squared equals ek over a half m. And then the final step is then to square root both sides. So v equals the square root of ek over half times mass. And again, you've got a 2.5 like on the previous ones, but mathematically they're exactly the same. So you can use either equation. Before we go any further, let's just look at some examples of kinetic energy in action. So the first example would be the elephant. Now we all know elephants have a very large mass. They can actually run very fast, and the combination of the mass and its velocity together, that's what's going to hurt if you're in a collision with an elephant. Likewise, a Formula One car, they're built for speed, and the faster they go, the far more kinetic energy they have. If you double the velocity, you're actually quadrupling the amount of energy that's in the car, and that's why motor racing people have to be ultra fit, because their body is subjected to lots of different directions and energies throughout the circuit. Another example is a golf ball. Now the golf ball that I've got just here, that's stationary at the moment, and anything that doesn't move has no kinetic energy because it has no speed or no velocity. However, when it's flying through the air, if it clunked you on the head, it would really hurt and potentially cause a lot of damage. And that's because, again, it's got a small mass, but it's got a massive velocity when it's flying through the air, and the combination of the two working together, that gives it the energy, the kinetic energy, and if it collides with your head or part of your body, the energy will get transferred, and that's what then causes damage. At the start of the video, you may remember seeing this picture of someone jumping out of an aeroplane. Now to start with, they've got a lot of gravitational potential energy. In other words, they've got a lot of height, and gravity is pulling them down towards the earth. However, as they fall, that energy gets transferred into kinetic energy. In other words, they speed up. So someone that jumps out of an aeroplane then speeds up as they fall down to the ground. The gravitational potential energy is transferred into kinetic energy. In another video, we'll look at more detail into the link between the two, but for now, let's look at some examples just referring to kinetic energy. So example 1, using the equation. Calculate the kinetic energy of an object when it has a mass of 15 kilograms and it is moving at a velocity of 10 meters per second. The first step with all of these is to highlight the key words or the key numbers in this case, and then think of an equation that might work to find out the answer. So just by luck, kinetic energy equals a half times mass times velocity squared, and like always, do write it down. I've included the triangle, and again, you might want to use that, you might not, but the option is there for you to choose. And as long as you've got the words highlighted, you can then start to use them. So the mass we said was 15, the velocity is 10, but the trick here is to remember to square it, and we've also got to multiply it by 0.5. At the start of the video, I mentioned about bringing your brain, a book, and a pencil. The third thing was a calculator. So at this point, that's when you're going to need it. And if you put that into a calculator, you get an answer of 750, and then remember to put the unit, the joule. Okay, let's move on to a second example. So example number 2, using the equation, calculate the velocity of an object when it has a kinetic energy of 250 joules and has a mass of 3 kilograms. Likewise, in the previous example, really important to put the equation, and then if you wanted to, you could put your triangle. So highlight the key things, 250 joules, we want to try and find the velocity, and we know the mass is 3 kilograms. Because we've written the equation, we can then write the numbers directly underneath. So we know that the mass is 3 kilograms, We know the energy is 250 joules, and we're trying to find the velocity. So we're going to need to rearrange the equation. So based on what we looked at earlier, we know that the velocity squared equals EK over a half m. So velocity, if we square root both sides, is EK over half m square rooted. We can now put the numbers in because we've got them written out. So 250 divided by 0.5 multiplied by 3, which is the mass. So we can put that into our calculator, and that gives us a velocity of 19.4 meters per second. On to some questions for you to have a go at. So I've labelled them with 1 chili, 2 chilies and 3 chilies. So that's just in the order of difficulty. So at this point, press pause, have a go at the 3 questions. You should now have enough information to give each one a go, and just be aware of the sneaky bit on question 3, give your answer to 2 significant figures. So when you're ready, press play and we'll go through the answers. Okay, let's go through question 1. So the first step is always to write out the equation. And then once you've done that, you can write in the values directly underneath. So we've got a mass, got a velocity, and we want to find the kinetic energy. So that's then a half, or 0.5 times 2 times 1.5 squared. And then 1.5 squared is 2.25. And it's a case of putting all of that into a calculator, which is then 2.25, and our unit is joules. So hopefully you gave that one a go and got it right. Let's move on to question number 2. So again, really important, just get into the habit of writing out the correct equation. So kinetic energy equals a half mv squared. So we can highlight what we know. So we know the kinetic energy is 350 joules. We know it's moving at 4 meters per second, and then we need to square it. And we're trying to find out the mass. So a half times mass, and then times our 4 squared. So we're going to need to rearrange the equation. And some people prefer the method of the triangle. So mass equals kinetic energy divided by a half times v squared. So we can put in our numbers, 350 divided by a half times 4. So that's the same as doing 350 divided by 2. So that gives us a mass of 175, and our units kilograms. So once again, I hope you got that one correct. Let's move on to question number 3. So I've written out the equation, kinetic energy equals a half mv squared, and I've also put a copy of the triangle at the top. So we want to calculate the velocity. The mass is 40. The kinetic energy is 2000. So we need to rearrange for velocity. So v squared to start with is kinetic energy divided by a half times mass. And then if we square root, so we can then put kinetic energy, which is 2000. And then rather than writing a half, I can write 0.5, and the mass is 40. So that's then the same as doing 2000 over 20. So that's then the same as doing the square root of 100. So our object is moving at 10 meters per second. So once again, I hope you got the third one correct, and very well done if you did. So that brings us to the end of our video on kinetic energy. And as ever, please do subscribe to any future videos so that you get a notification. And there is also an accompanying worksheet that you can have a go at as well. All the details are below. Thanks a lot, and see you next time.